Hello everyone. Today we are going to solve 11th question, that is find minimum in rotated sorted array. So let's just read the question, and the question says that suppose an array of length n sorted in ascending order is rotated between 1 to n times. For example, the array nums might become this if it is rotated 4 times, if it is rotated 7 times. Once the rotating array one time resulting this thing, and given a sorted rotated array nums of unique elements, return the minimum element in this array. You must write an algorithm that runs big O of log n time. So let's try to understand what question says. We are given an array that looks like, okay, so let's say we take first example, 3 4 5 1 2, 3 4 5 1 and 2. So this is an array. We have to find minimum element in this array. So the brute force approach is that you will go to each and every element, and you maintain a variable called min value. Initially you initialize with int max, or you can assign with 1e9, or you can say this is an infinity. So initially min value is infinity. Now as you go to every element, you will just try to update min value with minimum value. So it looks like min of min value and array of I. So this is the approach. Okay, I hope this approach is clear to everyone, like going to every element and updating my min value. So it is easy. Let me write its pseudocode, and the time complexity of this solution will be big O of n, and space complexity also going to be constant in this case. Now let's create a variable called min value. Initially we will assign it to infinity or 1e9. You can assign like in C++ int max. Okay, now for int I equal to 0, I is less than n, I plus plus. Okay, now min value is updated with min of min value and array of I. Okay, after the loop ends, we will return min value. Okay, so this is the approach of solving this question. Yeah, this is the brute force approach. Let's move to optimize this. Okay, so let me erase this thing, and we will optimize this thing and this problem using binary search. So let's see how. Okay, so in binary search we will have two pointers. Like, let me before this let me explain one observation here. Like, uh, this is rotated at some number of times. Okay, so initially question says that this is initially sorted like 1 2 3 4 5. Okay, now if you rotate it one time, then it looks like, if you rotating like this like this, then 5 will come in the front, then 1 2 3 and 4. This is one time. This is second time. If you rotate like this, then 4 comes to the front, 5 1 2 3 and 4. Third time will be, okay, so 4 is not here, so 3 will come in the front. It will 4 5 1 2 and 3 and so on. So here observation is that, like, if you consider any element, then you will find that one of its half going to be sorted. Like if you consider this 4, its left half is 3 and 4, and if you can see that its right half, that is 4 5 1 2. If you can observe that 3 and 4, that means its left half is sorted, but its right half is not sorted. Okay, so I'm trying to say that if you consider any element in the array, like it is sorted, it is rotated at any number of times, but you will find that it's one of its half going to be sorted. Okay, so let's try to consider another element. Okay, so let me consider this one, this 5 element. If you consider this one, its left half will be this, and if you see 3 4 5, this is sorted. But if you see its right half, like 5 1 2, this is not sorted. Let's consider one more element so that you can understand better. Let's try to consider one. This one, if you see its left half will be 3 4 5 1. Okay, so this is not sorted. If you consider its right half, it's going to be sorted. Okay, so we are going to use this observation here. Let me erase all of this thing. Okay, so in binary search, we always have two pointers like low and high. Low is pointing to index 0 and high is pointing to very last element in the array. So let's do, this is low and this is high. Let me do indexing 0 1 2 3 and 4. If you remember how we will calculate mid, it will be low plus high divided by 2, and in this case what is low? Low is 0 and high for now is 4 divided by 2, it will gives us 2, and mid is going to be this. So let me mark it with red color. This is mid. Okay, now we will see which half is sorted. Like in this case, which half is sorted? This is the left half and this is the right half. And as you can see, left half is sorted. So now let me erase this thing. 1 second. Okay, now its left part is sorted. Now we will have a min value, like we will initialize min value with int max. Okay, now we will get a left part is sorted. That means that what is the minimum value in this sorted, you can say segment, like this 3 4 5 is sorted and 5 is our mid and this is our low. So can you tell me what is the minimum element in this segment? You can definitely, because as you can see it is sorted, so the minimum element is going to be 3. So you will just update minimum value with min of minimum value itself and array of low. Why we are doing this? Because we know this is sorted, and if it is sorted, that means this is going to be low for this segment. Okay, so let me erase this, and now, okay, so we, 1 second. So we will find, we already find that in this range the minimum element is going to be this, so we do not need to go its left side and try to find minimum element. So what we will do instead of, we will go to its right half and we will try to find a minimum value. Okay, because we already find in this segment, now we will go to its right half. Let's see what right halves looks like now. Now our low pointer is going to be mid plus 1. So now the array looks like this. It will be 5. Okay, 5 not 1 and 2. Okay, let me do indexing. This is 3 and this is 4, and my low is this and my high is this. Okay, let's calculate mid. What will be the mid? Mid is going to be, what is low? Low is 3 plus high. What is high? 4 divided by 2, that is 7 divided by 2, and that is 3. So our mid is going to be this. So this is low and this is mid. Okay, now we will check which half is sorted. Like if you see this, its left half is also sorted and its right half is also sorted. So if you try to consider anything, like let's say its left half is sorted, so what left half would be? Like one, only one element. So we will update min value with 1. So whatever min value, we are going to update with minimum of, let me erase this and write it over here. So minimum value equal to minimum min of minimum value itself and 1 from here. It is low, so we are taking this low because it is sorted. We can take low as a minimum element in this segment. Okay, now we will find that left segment gives us the minimum. Now we will find in the right segment, so we will go to its right. Let's see how. Let me erase this thing, and if I zoom this now. Okay, so now the array looks like this. We only element only one element there. So this is low and this is high. Why this is low? Because our low is this. We will just do mid plus 1. So we will shift my low to mid plus 1. So now low and high both are going to point one element, and its index is 4. If you try to find its mid, it is also going to be this one. So let me mark it. This is mid. Okay, now if you try to find its left half or its right half sorted, which half is sorted. So if you consider both part is sorted, but if you consider any of them, like let's say in this case I am considering its left half is sorted. So in the left half, there is only one element. We will update with minimum value, like min value. We update minimum value with min value itself and 2. So after that, I'll shift my low to the mid plus 1, and it will going to be now our low and high looks like this. Our My high is here and my low is here. So as you can see, low is greater than high, so we will stop here. Okay, so I hope this is understandable. So let's try to code it. Okay, so let's move on code part. Okay, initially we have a min value will be initialized with 199, let's say, or int max. Now let me create a variable n, which is going to be store my nums dot size and two pointers low and high and minus 1. While my low is less than or equal to high, then int mid, we will always calculate mid. It will be low plus high divided by 2. Now we will check which half is sorted. So if my array of low is less than or equal to array of mid, it's not array, so it is nums of mid. If this is the case, that means our left half is sorted. So I'll update my min value with min value and nums of low, and after updating I'll move my low pointer to mid plus 1 because I have to go to its left half. Else if this is the not the case, then we have left right half is sorted. So we will update mid value equal to min value with nums of mid. Why mid? Let me write it. This finish the code, then I'll explain why mid. And we will move to its left half, so it will be mid minus 1. After that, after the loop ends, then I am going to return min value. Okay, let me explain why I'm taking array mid. Okay, so let's take an example, like if my array looks like this: 1 3 4 and 7 6. Okay, now let's consider this is my mid. Okay, this is my mid and this is my high and this is my low. Okay, if you can see, like it's right half is sorted. So if you try to find what is the minimum in this case, let's say 4 7 6, this is the sorted. Now if you find what is the minimum, so minimum is going to be mid because it is sorted. So minimum will be array of mid. That's why I am updating with min value with array of mid if the right half is sorted. Okay, so let's try to run this. Okay, this is accepted. Let me submit this. Okay, this is accepted. So thank you for watching.